All right, welcome. We're going to do 16A on the back, numbers 10 through 12. So there are 13 coins made up of quarters and dimes. So there's 13 made up of quarters and dimes. The total value is $1.75. How many quarters, how many dimes? So the first question, number 10, says write two equations, one for the number of coins and one for the value. So there's 13 coins total, and we're going to say those are made up of quarters plus dimes. It's just easiest to use the symbols associated with the numbers, with the coins, so we don't get confused. All right, the other one is the $1.75. That's our total. Now I like to just write that as cents, so that's 175 cents. And then how much is a quarter worth? Each 1 quarter is going to be 25 cents. So I say 25 times the number of quarters I have. And then each dime is worth 10 cents. So 10 cents times each dime will give me the total cents that dimes are worth. So the total cents that the dimes are worth and the total cents that the quarters are worth is the total cents that I have. So that's why these are our two equations. Number 11, how many quarters are there, and then how many dimes are there? So these are best solved with elimination. So I'm going to write the first one with all the big numbers here. And then I want to eliminate, and it's asking me how many quarters are there. So I want to eliminate the dimes. So if I take this equation and I multiply everything by -10. So I take this equation and I multiply everything by -10, then I can write it down here and I'll be able to eliminate the dimes. So remember to multiply it by everything. -10 times 13 is -130. -10 times q is -10q. And -10 times d is -10d. Now I can add these up. The dimes are eliminated. 25q minus 10q is 15q. 175 minus 130 is 45, and then my equal sign is right here. Then at this point, I just divide by the coefficient in front of q because I want q all by itself. So I divide by 15 and divide by 15. That makes q by itself is equal to 45 divided by 15 is 3. So there's 3 quarters in my $1.75. So if I just take this over here, that's usually the easiest one to go to, is how many coins there are. There's 13 coins total. 3 of them are quarters and some of them are dimes. So if I subtract 3, I have 10 is equal to D. So I have 10 dimes and 3 quarters. 17A, 5 through 8. I want to find 3 consecutive even integers such that the sum of the first and the second integers is equal to the third plus 4. So when I'm looking for even integers, the first one I'm going to label as n, but the next one needs to be 2 away. For example, if it was 10, my next even integer is 12, the next one is 14. Well, 12 is n is 10 plus 2. And 14 is n plus 4. So when I'm doing even integers, I want to count by 2's. n plus 2, and n plus 4. Now I'm going to write an equation with the unknowns. Now sometimes it might help you to just write it out with like first, second, and third, and then to plug in what those integers are. So as I go across the equation, it says the sum of the first and second integers. So the first plus the second. the sum of the first and second integers is equal to the third integer plus 4. So now I'm going to plug in what the second integer is, what the first integer is. So the first one is n, the second one is n plus 2. The third integer is n plus 4. Now somebody might ask, why do we need to put parentheses around it? In this case, it's just extra. It's helping me see that that is the whole third integer, and this is the whole second integer. Because I'm adding, it's fine if I were to leave it off. Sometimes it might say 3 times the third integer. In that case, you want them in parentheses because the third integer is n plus 4, and that 3 has to be multiplied by both. So I just get in the habit of always putting them in parentheses, and that way if I don't need it, it won't hurt me. But if I do need it, it'll be there and I will remember to distribute. So now we're solving for it. And now I can look at this and say, okay, there's nothing multiplied in front, so I can pull it out of the parentheses if I want. N plus 2, n plus 4 plus 4. I'm going to add everything together on each side that I can. So there's 2 n's right here, and then just the number 2. On this side there's an n, and there's 2 4's, which I can add up to be 8. Now I'm going to move the n over and move the 2 over. So to move the 2 over, I subtract it from both sides. And to move the n over, I subtract it from both sides. So 2n minus 1n is just 1n. This one cancels, and n is 6. So then my integers, if the first one, remember these were just examples, not the actual answer. So the first one was n is 6, and they were even, so it must be 6, 8, and 10. Now on number 8, when they ask me to check it, I'm going to go back up. The sum of the first and second. This is the first, this is the second. So the sum of the first and the second integer is equal to the third integer plus 4. So now I just want to check. 6 plus 8 is 14. 10 plus 4 is 14. And we're correct. Alright, the last one that we'll do is 17a, 13 through 16. So on the back of 17a, we're going to talk about consecutive odd integers. So when we're doing odd integers, we're starting with n, and let's say that the integer was 13. The next odd one is 15, the next odd one is 17. So between 13 and 15 is 2 numbers. So we're still using n plus 2, and then the next one is another 2 numbers, so it's n plus 4. So even though they're odd, we still use n plus 2 and n plus 4 to represent them. So this is our first, our second, and our third. Okay, 3 consecutive odd integers such that the first plus the third is equal to 3 times the second plus 3. So now I'm going to plug in with n's. The first one is n, plus the third one is n plus 4. 3 times the second one is n plus 2, plus 3. So this is why it's important to put the parentheses. Now we're going to solve. So when I do that here, I'll notice that I didn't need the parentheses because I'm just adding each of these. So n plus 4. But here I need to distribute this 3. So remember I need to multiply by the n and by the 2. So I have 3n plus 6 plus 3. Now I'm adding these n's together, so I have 2 n's. I only have one number by itself, plus 4. I only have one n on this side, so 3n, and 6 plus 3 is 9. Now it doesn't matter which I do first, but let's see. I'll move the 4 over, so I'm going to subtract 4 from both sides. I have 2n is equal to 3n plus 5. And that means I need to move the 3n over to this side, so I'm subtracting 3n. And I have 2n minus 3n. That's a negative n is equal to 5. So then I just need to change, I need n by itself, so I just need to move this negative over to this other side. I could say that I'm multiplying by negative 1. Two negatives make a positive, and this one is a negative 5. So I'm just moving that negative from the n to the other side. Now it's a negative number, but that's okay. We can still have integers that are negative. Now the tricky part would be, this is our first one. Our second one is n plus 2. So our first one is negative 5. Our second one is n plus 2. If we're adding 2, we're getting less negative. So we should be negative 3. And then if we add another 2, we get negative 1. So even though this is negative 5, we're going to negative 3, negative 1. This is our lowest number always, but sometimes when it's negative, it's a bigger negative, but it's still our lowest number. And then the last part is we just want to check it to make sure. So we go back up and read our equation. The first plus the third. The first plus the third. So negative 5 plus negative 1 is equal to 3 times the second plus 3. So negative 5 and negative 1 is negative 6. Here, 3 times negative 3 is negative 9 plus 3. Negative 9 plus 3 gives us a negative 6, and that equals a negative 6, so we're correct. You have no test this week, so... Oh, you do have a test this week. Am I wrong? I don't have my book with me. So if there's a test this week, then you're going to write on it something like, "I'd like bonus points, Mrs. Berry." And I'm going to say, "Well, you must have watched the video. I'm so proud of you." And there may be bonus points involved. All right, hope you guys have a good weekend.